Algebra 1 students, welcome to your 3.1 notes. We're going to look at inequalities and their graphs today. Go away, Mr. Thornburg. Now that he's finally gone, we can focus on actual mathematics learning. Alright, so let's take a look. First of all, with inequalities, we have 4 symbols we need to know. I believe this is all review for you, but I just wanted to list the symbols and show you what they would look like. You'll notice on the less than symbol or the greater than symbol that we have open circles at the end of the line. That represents that those points are not actually included, where when it's greater than or equal to or less than equal to, we actually have filled in dots, closed circles as you might hear them called sometimes, that show us that that point is included. And one thing I didn't do, I should read this definition. A solution to an inequality is any number that makes the inequality true. That's what we're going to look at to begin with. So, number 1, it says 3y plus 5 is less than 20. So what I'm going to do is plug in a value for y. We're given 2 is our number, so I'm going to do 3 times 2 plus 5 is less than 20. That would be 6 plus 5 is less than 20. So 11 is less than 20. And we know that that's a true statement, so we would say for A that the answer is yes. Okay, for B, we're going to do the same thing, but this time we plug in 0 for y. 3 times 0 is, of course, 0. Plus 5 is 5. And we know that 5 is less than 20. But watch what happens when we get to part C. And this one we'll do 3 times 5 plus 5 is less than 20. 3 times 5 we know to be 15. And 20 is less than 20. That's not true. 20 is not less than 20. It's equal to 20, so we would have to say no on that one. Alright, same instructions for number 2. Let's look at part A. We'll do 3 in place of n, so we'll do 3 minus 3 divided by 2 is less than or equal to 4. That's 0 divided by 2 is less than or equal to 4. And we know that to be true, so we can just go ahead and put yes. For part B, I'll work over here, I suppose. We'll do 3 minus 2 divided by 2 less than or equal to 4. So that's 1 over 2 less than or equal to 4. Again, that's a true statement. So we would say for part B that the answer is yes. Why don't you pause the video and do part C and then hit play and see how your answer compares to mine. Okay, you can see my work on part C. I was running out of space, so I had to kind of slide over here. But essentially, 3 minus negative 10 is the same as saying 3 plus 10. And we know that 13 halves is more than 4. And this says it's supposed to be less than, so we would just simply write no. Alright, so let's graph some inequalities. Now we'll notice on number 3 it says z is greater than 3. And what I know from this symbol, first of all, it tells me I need to get numbers that are bigger than 3, but it tells me something else too. It also says it doesn't include 3. So I know at 3 I need an open circle. And then since it's greater than, we would just simply choose all the numbers that go to the right. Something like this. Didn't like my arrow I had at first, so I'm trying again. Alright, let's take a look at the next one. Negative 5/3 is less than p. Now we're used to seeing the variable on the left, so it might be wise to go ahead and switch that and make it say p is greater than negative 5/3. I basically just flipped the inequality around. Now you have to think about negative 5/3. That's the same as like p is greater than negative 1 2/3 or 1.67, something like that. So we're going to estimate negative 1.67 and then put an open circle. And again, this is a greater than, so our line should go to the right. Okay, on these next two, we're actually working the opposite direction. where we've got the graph given to us and we want to write the inequality that matches it. So on number 5, one thing I see is that we have an open circle. That tells me it's not equal to. The other thing I see is that the graph is going to the left. Putting those two pieces of information together, it tells me it's going to have to be x is less than some number, and that number is where the circle is, so x is less than -1. Okay, number 6, we have a filled in circle and it goes to the right. So right there I know not only is it equal to, but it's also going to be greater than equal to, and our number is -3. So any value that's at least -3 would satisfy this graph. On the first one, any value less than -1 would satisfy the inequality. Alright, so let's put a little application to this. Define a variable and write an inequality to model each situation. The school gymnasium can seat at most 1,200 people. Now again, we need to define a variable, so I'm going to say P is the number of people. You could use any variable you'd like. It still needs to represent the number of people. Some of the key words here: at most. So that means the most people it can seat is 1,200. It can seat exactly that number or any number less than that. So we would simply say P is less than or equal to 1,200. You really have to focus on the words that are there. Don't let them confuse you. A word like at most means less than or equal to. Okay, for the track meet, the runner must run faster than 44 seconds to beat their fastest time. Okay, so let's say our variable this time we're looking for is t for time. So what we want to do is run faster than 44 seconds. And so what we'd have to look at is, okay, that means I need to run less than 44. Could I run equal to 44? Well, let's see. The runner must run faster than. Faster than doesn't say anything about at least as fast as or the same speed or better. So if they want to beat their fastest time, it would be t is less than 44. For our last slide, numbers 9 and 10, which somehow that 10 disappeared. I'm going to go ahead and type it in right now. You can add that to your notes as well if it's important to you. It's not some huge deal, but it should be number 10. Don't know what happened there. But for 9 and 10, we're supposed to take an inequality and change it into words. So what I'm going to do is, for number 9, I would say n is less than 3. That's all there is to it. For number 10, z is greater than or equal to 3.14. So really nothing too complex about these problems. Just put into words what you're seeing in the inequality. Alright, for 11 and 12 we'll work the opposite way. We've got the words version written for us, and we need to change it into an inequality. So v is greater than 10, piece of cake. V greater than 10. Okay, number 12 takes the difficulty up just a notch, but we're going to write it just like it says, 2 more than k. So that would be k plus 2, or you could write it as 2 plus k is fine, is less than -3. There's our inequality. Now later on we'll go ahead and solve that inequality and we could graph it, but for today we're just looking at some of the introductory aspects of inequalities. Alright, there it is. Pretty fast lesson. Make sure you bring your notes and answer the questions to the side of this video as you finish. Have a spectacular